Hi there, good evening. I'm Dietmar Winsker. I will be presenting the webinar. Welcome to everybody. I trust you can see and hear everything, but it seems to be working quite well these days. My title for tonight's webinar is Our Body's Many Cries for Oxygen. I changed it slightly and I'm leaning onto that book called what is it called again? Our Body's Many Cries for Water. And I thought that was a good title. So I made it Our Body's Many Cries for Oxygen. Um, as you see, I'm a technical man. For those who are maybe joining here for the first time, I'm not a medical guy, I'm an engineer. And I've been in the BEMA business for 13 years. I've learned quite a bit. I've translated quite a bit in the early days. And I think I know enough about biology and BEMA and how it relates to physiology that I think I can talk about it. All right. I think the question I want to ask here this evening, and when I say evening, I say good morning to the people from the United States, but this is mainly for the South African audience, but you're all welcome, of course, from wherever you are. What do we want in terms of health? Well, I think what we mostly aspire to is vitality and performance and fitness, mental and physical performance. Yes, we want our health, although it's very difficult to describe what that is, definition wise, but we all know when we have it. We certainly know when we don't have it. But I think what we're all after is quality of life. And especially as one gets older and one sees aging and all the ramifications of aging, then quality of life is probably the highest good you can have as you get older. What do the following pictures have in common? And I'm going to run through them very quickly. It's a rhetoric question, of course, but I just want to show you. Back pain, high or low blood pressure problems, non-healing wounds, diabetes 2. In other words, you're not born with diabetes, but it's an acquired diabetes. Sleeplessness. I'm surprised how many of my friends, my contemporaries, already suffer from a lot of sleeplessness. Now, it could be worries, it could be concerns about all sorts of things, but there could be other reasons for it too, more physiological reasons. Migraine and headaches are not unknown, and some people suffer from them for years. Yes, really for years. I'm surprised that that exists. As a person who's always been blessed with good health, I'm actually regularly surprised how much suffering there is of all sorts of things. The word migraine is for me just a word. I don't know, fortunately, what that really is in terms of experiencing it, although I've had the odd headache. Tinnitus, this continuous noise in your ear, um, those are things that bother some of us. Depression, it is such a general thing today that it's almost seen as as part of the fallout of civilization, at least in the West. Multiple sclerosis, much more widespread than I ever thought. And possibly it is because one is in the health business that you have more contact to such things. Guillain-Barré syndrome, which is really a debilitating ailment. And I've come across many people with that already. Chronic fatigue syndrome. There are days when I think I got it. But fortunately, because of the BEMA, as you will see later, I recover pretty quickly. So it never becomes chronic, really. But kidney ailments are also very frequent. And fibromyalgia, which, although I got this picture of the internet somewhere, the trigger points that are indicated there with red dots, when I've spoken to a neurologist, he says fibromyalgia is a very, very difficult ailment, but it is actually a malfunction of the control center in the brain that manages all the sensory inputs that you get into your brain. And that gets very confused if every little bump and nick and feeling and emotion and input through the eyes, ears, touch, whatever, is channeled through that one tiny little part of the brain, and there is a bit of an overload, and then the pain comes out all over. Anyway, it's a more difficult explanation that I could give you, um, but I just wanted to mention it. Fibromyalgia, an ailment that many people suffer from. Nobody really knows how to treat it, or that is what I pick up. But I may be wrong. There may be physicians who can treat this. Neurologists apparently know exactly what it is. Most GPs look for the other symptoms and try and treat them. Fractures and broken bones. Remember, I'm just giving you a listing here. Osteoporosis. What is common with all these things, including osteoporosis and rheumatism and things like arthritis? And all these ailments have causes at cellular level. That's why I put them up there. And I'm sure there are many, many, many more, maybe hundreds, maybe thousands of ailments that really have their cause at cellular level. And at cellular level, you must understand, we consist of about 100 million individual cells, each one specialized and there for a specific job, building specific proteins and other chemicals and doing their thing. But if that cellular metabolism, and what we mean by that is really the chemistry inside there, which is meant to work according to a very fixed structure and order, a very fixed process, if that is not working well because of poor energy production at cellular level, and this energy in the cell is a chemical called ATP, adenosine triphosphate. And that adenosine triphosphate is generated with little generators inside the cell and then used up to give a good cellular metabolism. But if the metabolism is bad, it's because of poor ATP production. And the ATP is produced by oxygen and nutrients. And if that doesn't work because there's poor blood circulation, then we've got a problem. But you see, I put this explanation in reverse. It really starts with poor blood circulation, which reduces the oxygen supply, which reduces the energy production, which results in poor cellular metabolism. And as you will see during the course of this webinar, that means many cells are not doing what they're meant to do, and the signal your brain gets is pain or some other discomfort, as you will see in a moment. Now, of course, our medical world treats symptoms, and that is understandable. I always want to emphasize that with the BEMA, I'm not talking against medicine or physicians or the way the world is put together in a medical sense. However, symptoms are something that we can sense, that we can feel, and usually it's in the form of pain or some uncomfortable feeling of some sort, a pressure or maybe a sharp pain, whatever it might be. However, long before we have these symptoms, it is my viewpoint that there are a lot of unnoticed developments down there in the body that actually cause these symptoms. But because they are unnoticed, we don't know something is happening. If we have impaired blood circulation, now you must know the blood is a transport highway, a transportation highway for the oxygen and for the nutrients. And if that isn't working for whatever reason, in terms of open flow channels, in terms of sufficiency, in terms of blocked areas to certain tissues or certain organs, then the next step is that there will be an oxygen insufficiency. Because if the blood cannot get right down into the capillaries, then there will not be enough oxygen to let the cell metabolism in the area of those particular capillaries function well. Now, if there is oxygen insufficiency, that means the ATP production that I mentioned earlier on, the energy production at cellular level, is in trouble. And if that happens for a longer period of time, it could become chronic. Now, if you're 20 or 30, you recover very quickly from a temporary shortage of ATP production. The body is resilient, it is young, it can fix these things relatively easily. And for a short time, it can do very well with a lower level of oxygen or even anaerobic situation, an anaerobic situation, as you see in high performance sports very easily. Of course, if that carries on and on and on, the cell chemistry isn't working very well anymore, and more cells will start to dysfunction. All that means is that these cells that are programmed to do a certain thing do not get the energy to do what they're meant to do. It's like when you have got no gas or petrol in your car anymore, it will not be able to perform. It's that simple and as profound as well. And so, if there are more and more cells in one particular organ that are, in good old vernacular language, packing up, if they pack up, and so let's say they are in the pancreas, then you have a whole couple of millions of cells not producing enough insulin. And then for the first time, you have a symptom, and the doctor will examine you and find that you have the onset of diabetes too. So I hope you could follow this. And I drew it like an iceberg because the symptoms are really only the tip. There's stuff going on down at the bottom. And the real problem is lifestyle. And I'm as guilty as the next person. Guilty in inverted commas. Some of it is intentional, by volition, and some of it is just circumstances. But lack of regular exercise is definitely one of them, because we have predominantly sitting activities. Poor breathing habits. I think even I, with the age of 63, can still not breathe properly. But I've never smoked, so there I've got one advantage. There's psychological stress because we all have spouses, employers, employees. We've got road traffic, we've got chasing deadlines, etc. There's environmental stress from the air we breathe, especially in the big cities. There's environmental stress in terms of noise pollution, air pollution, water pollution in some areas. And then there's, of course, malnutrition in the sense that us in the Western world, it's not that we don't have enough. In fact, we have too much to eat, too many calories, too little exercise, poor breathing habits, and all these things. And so we end up like these five characters there in the cartoon, as you can see. And it's not a pretty picture. The common factor of all these things, or the common underlying factor of this, is poor circulation, poor blood circulation, and resulting lack of oxygen. And the lack of oxygen is a major problem for the body. As you know, we can live without food maybe up to 40 days or longer, but not without oxygen. There we are counting the time in seconds or minutes at the most. And of course, the other one is poor nutritional habits and lack of motion, locomotion. I move a lot in aeroplanes and cars and boats, but I do not use my own 2 feet, and or not too often at least. You know, they say the average distance that a person walks these days in the Western world is 800 meters. That's what, 900 yards or less per day. So, in the past, we did a lot of exercise in the fresh air. Today, little exercise, poor nutrition. You come home, you're exhausted, you're stressed out, and all you can do is eat some fast food, have some probably unhealthy drink, and fall asleep on the couch in front of the television. We should be doing exercise in the fresh air and not watching others do exercise in the fresh air on television. But you know all that. Let's get back to basics. For our bodies to function properly, we require oxygen and nutrients, as you know. We also require sufficient amounts of water because our bodies consist about 67% of water. The brain, as terrible as what it sounds, is about 98% water. How's that for putting us back on the ground? The oxygen and the nutrients are converted to this ATP at cellular level so that this very highly complex molecular chemistry can really proceed according to the program. Whoops. And this chemical process, which we can call metabolism, generates waste products, and toxins possibly have to be removed also from the cells. And for that, we need a blood circulation system, and the lymphatic system also has a big role in this. And so what is sketched there schematically as the whole blood circulation system is really the body's transportation highway for all materials that have to go to the cells and have to be removed from the cells. So at this level, biology isn't difficult. But don't be fooled. Biology is extremely complex, much more complex than anything I have ever done in engineering. And I did some pretty uh, complex things in my career. Now, blood circulation is essential. Blood circulation means 15,000 liters a day that our heart has to pump through our bodies, and about 1,200 liters a day go through the brain alone. That's quite something. And this heart isn't very big, but that circulation is essential. But if you think that we have 120,000 kilometers, that's probably what, 90,000 um, 90,000 miles or so of blood vessels, of which 75% consist of diameters of less than a fifth of a millimeter. That is the microcirculation. And here comes the big, miracle in a way. The heart alone cannot possibly pump the blood through 120,000 kilometers of blood vessel. You need other mechanisms to promote the flow of blood through the smaller and smaller blood vessels right down to the capillaries. And the capillaries um, are right down to about 7, or let's be generous, 10 thousandths of a millimeter. And the heart must pump, but it cannot pump through those small pipes. So we need other mechanisms. Let's call it the microcirculation. Now, what the BEMA does is something very physical and very simple. It triggers the body so that it can regain its self-healing effect. Because let's face it, the body is self-healing. With all due respect to the medical profession, the body itself is capable of healing itself, but the medical profession, and the BEMA for that matter, and other modalities only enable the body to heal faster. Now, this self-healing effect needs a stimulated microcirculation, because that microcirculation has to get the essential supplies to and remove the other substances from the cells. When that is all working, especially the oxygen and the nutrients getting there, then at the bottom of this little cycle, we have an improved energy production. That means better ATP production. And this better ATP production at cellular level means that the biological chemistry at molecular level works so much better. No, not just so much better. It actually works the way it is meant to work. And if that is all working, then the regulation processes by which the body controls its own body temperature continuously, hormone levels, digestive processes, brain processes, you name it, blood pressure, high, low, whatever, the body knows how to regulate it. It is built in, it is in the DNA. So when this little cycle, as simple as what it looks, but as profound as what it is in its working, if that cycle is working well, then everything is well. And the last time it was like that was probably when you were 20, So it has maybe changed a little bit over the years. So the BEMA improves this microcirculation by giving a physical trigger to the body to help the smallest blood vessels in a dilation and contraction motion, which we call vasomotion, to push the blood forward. And it opens capillaries. this tiny network of tiny little blood vessels, of which in the point of a ballpoint pen, just sort of to get a wow factor here, there are about 3 to 5,000 individual capillaries inside the volume of the ball of a ballpoint pen. Now you'll have a bit more respect for your body again, maybe. Now, 75% of our blood vessels, as I said, are of this small diameter size. The BEMA also improves the energy production because it gets the oxygen to the cells. And these little engines here, this green rotating chemical engine that lives in the mitochondria, in their thousands, in each cell, they produce this ATP, which is a substance that gets immediately used up by the cell again to do the functions the cell has to do. And this energy production, if you could heap it all on one heap of ATP, imagine a big bag of ATP that is about your body weight. And that gets generated and used up within seconds every single day in your body. And that's why you need oxygen, and that's why you need nutrients. The BEMA also has a tremendous effect on partial oxygen pressure. And this graph that I've shown you here, if you look at the top here, the vertical axis is the partial oxygen pressure, which is really just the component of the air that is due to oxygen. So there's a bit of an old-fashioned way of measuring pressure here. Millimeters of mercury is very old-fashioned. Only medical people and pilots still use millimeters of mercury, really. And that's the vertical axis. And on a horizontal axis, we have the biological age of the people under consideration. And what a professor in Germany has done in the 50s is he's just taken a couple of thousand people off the street, plotted their partial oxygen pressure, which is relatively easy to measure, although measured indirectly, but it can be measured very easily. He determined this top curve, which starts at about 96 to 98 millimeters of mercury. And you see that by the time this person is 50 years old, it has reached that critical level, 80 millimeters of mercury, which is really the cutoff point for intensive care units at hospitals. As soon as a patient drops below 80 millimeters of mercury, the nurses and the doctors start running to try and get that back up. But you also see that this curve goes down. By the time you're 80, it is below 70. And that is a direct indication of how much oxygen will be absorbed by your body. So it stands to reason that if we could get the partial oxygen pressure up back to 96 millimeters of mercury, even if you're 50, 60, or 70 or 80 years old, that would be great. Then we had a lot more oxygen available. Now, when people have serious ailments, they sometimes go into hyperbaric chambers, and hyperbaric chambers are really nothing other than to increase the partial oxygen pressure. People are under high pressure in these hyperbaric chambers, and more oxygen is meant to go through the body in the natural way via the lungs to alleviate whatever the problem might be, from wound healing to asthma to all sorts of other things. Now, the interesting thing is, if you take people with a very low partial oxygen pressure, and here is an experiment that was done somewhere in Europe, where they took a couple of guys and their average was 70 millimeters of mercury, partial oxygen pressure, and they treated them on the old BEMA 3000 for a whole 8 minutes a day. Then over time, if you see the treatment here in weeks, of 6 weeks, but a daily treatment of 8 minutes, every single person in that group that had an average of 70 was suddenly up to where they should be. And that value, what it should be, varies a little bit with the altitude that you're living at. So in Denver, it will be a bit lower than in LA. But it varies relatively little for you and me. But the interesting thing is that every single person after 6 weeks was back there, which was, let's say, ideal. And that is an amazing thing. So we have seen a couple of things that the BEMA does that are very conducive for our body's chemistry at molecular level to work much better.